Hello, we're glad to be here with you today to talk to you about CodeCarbon, which is a Python package that allow developers to monitor their um, emission, the emission, carbon emission due to their code. I'm here today with Benoît, who is a data scientist in the French Parliament, who is president of the CodeCarbon Association and the main maintainer of the package. As for me, I'm a data analyst. I used to be an active contributor. I'm less now, and I'm working at Lincoln for the moment. And we were very glad to be at Green IO because it's for us a great place to meet people that do think that the environmental issue of numeric uh, is becoming critical. We have a lot of people talking about very amazing experiences, and it was very important for us because in CodeCarbon we get two mottos. The first is if you don't measure it, it doesn't exist, and the second one is be active, don't be passive, be part of the solution, not the problem. So how do we pretend to do that? That's through a Python package because we were originated in a AI lab. So as you may know, in data, Python is quite popular. And we were born in the Mila lab, lab in Montreal, in Quebec, um, under the supervision of Joshua Benjo, who is one of the father of the AI. He received the Turing Prize in 2018 with, in the meantime, of Yann Lequin, who is now working as a lead AI at Meta, and with Geoffrey Hinton, who was working at Google, but he stays in academics. And with his students, he was running more and more experiences about machine learning and AI, and he was becoming more and more aware that the energy consumption of their model was becoming an issue. And he, with the students, he decided to create a tool that was able to provide three things. The first is to get an idea of magnitude of the power consumed by the code and its impact on the environment. As you may know, in Quebec, the electricity is quite carbonated, as Canada is a fuel producer in Alberta, so the petroleum is quite and gas is quite cheap. And they need to have some comparison points so they can compare their run one to another to know the one who is was the most efficient in terms of power consumption. And then they need to have something that was almost real-time measurement while the code was running, so they can know which part of the code was the more greedy, electricity greedy than the other, and so they can fix it or try to fix it. So how do they do that? They created this package, they initiated this package that is monitoring the electricity consumption of the main computing part of the computer, and they multiply it with the carbon intensity of the electricity of the region they were. So this was in 2019. In 2020, they reached out for Data for Good with this project, and they said, we want to make it available for for the world, maybe let's say that, make it more wider, that it's not only in our lab, but it can be used by anyone. And that's at this time that Benoît Courty entered into the project, and later on I would join. And now they're still mainly maintained within the community, that have a good community. And what did we do with this package? First, we created an API so we can load the data to your own database or send it to a dashboard that we created at this occasion. And we had a recurrent issue that was that our dashboard was not secured. We didn't have in our community some people able to make authentication. So thanks to Mozilla Foundation, we were able to do this this year, and it will be coming quite soon. And Benoît will show you a bit later on what we managed to do this year in 2024. So as I said, the main aspect of that CodeCarbon is to provide a measure, some metrics about your carbon intensity. It's not meant to be accurate or really precise. It's just meant to have figures to discuss and to begin to work with. So we monitor three things: the CPU, the GPU, and the RAM. CPU and GPU are we try to detect what device you got, what component you got on your computer. And for the RAM, for now, we're working with a constant, but we are trying to make it more accurate in the near future. And when we get this power consumption of your computing component, then we multiply it, sorry, with the carbon intensity of electricity of your region. And for that, use either static data from our world in data, or we use an API from electricity map that permitted to get quite real-time estimation of the carbon intensity of your region. And as you can see, it can be a huge difference. This was last Friday, so just 1 week from now, in the evening, a bit later than when we are recording that. But in France, each kilowatt hour was 51 gram of CO2, where in Poland it was 900, yes, 900 gram per CO2 per kilowatt hour. So depending on where you are and when you're running your code, your impact is going to be really, really different. And during Green I/O, we have this incredible opportunity to have two companies, Electricity Map and Black Market, that make some recs about how they change the location of the data center, and that had very good results about the reduction of emission. Black Market was talking about reduction of about 30% of the carbon used by the data center, so we can really make something different by that kind of move. Another thing, just before I give the room to Benoît, is that for a long time we discussed about training of the model, as we initiate in the AI lab, where we really concentrate on the training of models, because it is and it still is consuming a huge amount of electricity, and then by default of carbon. But nowadays, with the increased use cases about AI gen or AI gen, or use of daily use of this kind of product, we saw that inferences are becoming more and more potent in the impact, the total environmental impact of AI. And just a friendly reminder that sometimes less is better, and that if you use AI, that is a powerful tool and can make incredible things, use it for things that need it. If you use AI to generate a recipe of apple pie, this is useless. You will you will consume between 4 times to 1,000 times more carbon than if you just make a Google search about an apple pie. So just keep that in mind before using your ChatGPT or your Gemini at home and in your use case. And now I will let Benoît talk and make you a demo of CodeCarbon.
Thank you, Marion. Yes, so CodeCarbon is a Python package, as Marion said, and it's quite simple to use. Maybe for you have some to be able to run Python code on your machine, but you could at the upper left you could see that you just install it with a pip install CodeCarbon, and you just have to do a little bit of config with CodeCarbon config, and after you run CodeCarbon monitor, and you will see what you see on the right. With CodeCarbon, looking at your hardware and identify it and monitor it every 10 seconds to check how many energy has been used and convert it in emission, like Marion explained. And if you are a Python developer, you could see below that you just have two lines of code to add to your existing code to monitor it. So we try our best to let it be very simple. And I will show you a quick demo of how to use it in Google Colab. So you could do it at home if you want. So let me show you these notebooks. So it's a notebook. We will use a LLM locally on Google Colab to write a LinkedIn post about this talk. So you have to install some package. After we import them, we configure CodeCarbon to upload to our API. So I will show you the emission of this demo on our dashboard.
Benoît, can you zoom in? I think it's quite small.
Oh yeah.
Thank
Sorry. Thank you. And so we run the tracker, and maybe I will run it for real. And the tracker, you could see the tracker from the CPU and the GPU we will be monitoring. And he registered to the API. After that, we download the model, and we could start the tracker here, as you can see here. And we also load the model, and you could see during the model is loading, CodeCarbon is monitoring. You see many logs because I set it to write logs every time, so you could see things happening. But if you use it in a real project, you could lower this logging level. And after all this code is only for LM, so I won't comment it. And now we could ask, this is a prompt we send to the model. We ask him to write a little post about our presentation at Green.io. And the model starts generating, and while CodeCarbon is monitoring it, and it also you could see that we give you an estimation of what will happen in the amount of emission if you run this for the whole year, and also the real-time emissions, right? And after that, we could stop the tracker, generate the post, and you could see here that CodeCarbon writes by default a CSV file where you could have all your runs of CodeCarbon and the emission. It's a historical method of using CodeCarbon. And yeah, we could see the post that has been generated by our LLM. So you could copy and paste it to LinkedIn. And now I will show you what happened on the dashboard. If I reload it, we could see here a little green dot for the emission based on the run we just made. And so we could see here the emission rates that progress during the use of the model. And for example, if I use click on another dots, you could see the monitoring. There is also a reduction in the emission because the GPU was paused, for example, in this during this training. And our dashboard give you also the energy consumption in kilowatts and also the emission of CO2, and it gives you an estimation of, to give you more sense of what it means. It tells you, for example, here, 6 kilowatt hours of energy means 2 days of watching a TV, or almost 3 kilometers ridden with a fuel car, to give you more sense about carbon emissions. So that's all for the demo. And this is our old dashboard that is online. And yeah, I forgot to say that this new dashboard is not yet in production, but it will be soon. Maybe it will be our Christmas gift. And so CodeCarbon support PyP for installation, also Conda. You could run it as a command line tools if you don't use Python for your project, or if you don't want to add it into your project, you could use it. For example, if your project is in Java or JavaScript or everything, you could monitor your servers. We also support Decorator and Context Manager for Python. We support GPU from NVIDIA and soon from AMD. And we support CPU from Intel and AMD via Rail, and we also support Intel with Power Matrix, Mac Silicon also. We also have fallbacks if we can't monitor your hardware. Well, CodeCarbon do many things, and we support also many outputs. You could have CSV file, you could upload to APIs, to your own APIs with a webhook, also to Prometheus. We also support some logging system. And as a conclusion, CodeCarbon doesn't tell you what to do to reduce your emission, but you could use it to monitor what's happening on your machine. And for example, if you change your model, you could see, oh, this model is better because it has more emission, or you could, what is best is to use it, for example, if you increase the accuracy of your model by 2%, but you increase the emission by 20%, maybe it's not so a good thing to put this model in production. So CodeCarbon help you do this type of assessment. But as you could see, I put it in I emphasize the keep hardware longer, because CodeCarbon don't tell you what is real-time emission, but you have to think about the emission of the building of the hardware. Because if you change your hardware every 6 months, CodeCarbon will tell you that it's a good way to do it because it's more efficient, but you have to think about the whole cycle life of your hardware. And so for developers, we have here some things you could do to your model. You could fine-tune a smaller model to your needs, so it will be more efficient. You also could change the location of your computing to a location who have greener electricity. And you could use optimization tools like Zeus. It's a tool that reduce the frequency of the GPU to allow you to reduce your electricity consumption without reducing the accuracy or the time of training. And so, yeah, there are many things you could do to reduce your emission, and CodeCarbon will help you to monitor this. And our future work, as I said, is to release the new dashboard and new API with authentication. We are also building partnership with observability platform like Logfire to integrate into existing monitoring solution. And we are also adding hardware support to CodeCarbon and trying to have partnership with data centers to have better support. And we keep presenting CodeCarbon to recruit users and developers around the world. So you are welcome to contribute. And thank you for listening. And I thank also Mozilla for supporting us this year with a grant. Thank you also Data for Good to support us, not with money, but with greetings and people. There is really a nice non-profit. And Clever Cloud for powering our dashboard and our server. Thank you.